So then let's start. Well, welcome everybody to this. Welcome everybody to this media call. It's our first media briefing on Switch, which is an exciting technology development project supported by the European Union's Clean Aviation joint undertaking. My name here is Markus Wölflith. I'm the head of corporate communication at MTU. And MTU, as the coordinator of the project in the context of this Clean Aviation initiatives, we are delighted to play the role of today's host. But for sure, we are not working alone in this initiative. And having said that, I'm glad to welcome the speakers from all industrial partners during this call. I'm very happy to introduce to you Dr. Klaus Riegler, Senior Vice President, Technology and Engineering, Advanced Programs at MTU, Graham Webb, Chief Sustainability Officer at Pratt & Whitney, Mary Lombardo, Vice President, Applied Research and Technology at Collins Aerospace, Henrik Rannemann, Vice President, Global Technology Center at GKN Aerospace, and last but not least, Karim Mokadem, Head of Electrification at Airbus. Before I hand over to them, I'd like to cover some logistics. These 5 speakers will give you a short overview in the next, let's say, 20 minutes of the Switch project, and after that, they are ready to take your questions. To raise a question, please raise your hand virtually here in the Teams chat if you want to ask a question. We will then open the microphone to you, and you can ask your question in person. Please indicate if you would like to pose your question to a particular speaker. As mentioned in the invitation, any information shared today is considered under embargo until we send out a press release tomorrow, which will take place then at noon at Central European time or 6 a.m. Eastern Standard Time. So we appreciate your agreement not to publish reports before, but for sure you can prepare them. Also under this embargo, and to make it easier for you to prepare your reports, we will provide you with a press release following this briefing. And of course, me and my colleagues will be at your disposal should you have any further questions after this briefing. So having said this on the logistics, it's now time to start with the real content which you're looking for. So Klaus, may I hand over to you?
Sure. Thanks very much, Markus. And a warm good morning or good afternoon to everyone in the call. I hope you can see and hear me well. As you probably all already know, the European Union's Clean Aviation joint undertaking recently announced funding towards 20 groundbreaking technology development projects aimed at making future aircraft more sustainable. And that's including the Switch project, which will be led by MTU. Switch is an acronym standing for Sustainable Water-Injecting Turbofan Comprising Hybrid Electrics. And it will be a collaboration between a consortium of leading aerospace companies, including MTU, Pratt & Whitney, Collins Aerospace, GKN Aerospace, and Airbus, as well as universities and research organizations spanning 7 countries in Europe and the United States. The project costs are shared between private and public partners, the European Union's Clean Aviation and the UK Research and Innovation programs will contribute very generously to the overall project. Switch is focused on 2 revolutionary technologies for future aircraft propulsion systems. The water-enhanced turbofan, which we abbreviate with WET, and hybrid electric propulsion, to demonstrate technologies driving fuel burn and hence CO2 reduction, as well as reduction of non-CO2 climate-relevant emissions. We aim to demonstrate the potential of these technologies to improve fuel efficiency and hence reduce CO2 emissions by up to 25% compared to today's state-of-the-art propulsion systems for short and medium-range aircraft, to reduce NOx emissions by about 80% and to reduce contrails. And furthermore, above and beyond, we will harvest synergies between both technologies. And now over to you, Graham.
Thanks, Klaus. The switch concept will take full advantage of the GTF engine architecture to significantly enhance both efficiency while at the same time reducing emissions across the full operating system of the aircraft. The project is a key opportunity to develop technologies that will further extend the efficiency of the GTF architecture, which since its introduction in 2016 has already helped avoid almost 10 million metric tons of CO2 emissions through the improved fuel efficiency of about 16 to 20% over prior generation engines. Since the GTF entered service in 2016, it has enabled single aisle operators to save about 1 billion gallons of fuel and growing. With the switch, the revolutionary wet and hybrid electric technologies will be integrated together, designed to deliver a step change reduction in emissions and also improving efficiency or reducing energy across the full operating system of the aircraft, while also maintaining reliability and operability. The technologies that will be developed as part of it will be fully compatible with cleaner aviation fuels such as sustainable aviation fuel and will be looked at for hydrogen. We'll be developing more energy efficient aircraft systems at the same time and supporting the transition towards the greater use of sustainable aviation fuels, which is critical to the aviation industry in terms of our ambitious goals to significantly reduce aircraft CO2 emissions by 2050 and beyond. The cross-industry collaboration that we're exhibiting today in delivering the technology breakthroughs needed to make net zero emissions aviation a reality. Now we'll go back to Klaus to walk us through the wet concept.
Thank you very much, Graham. We have the next chart, thank you. Well, the MTU's wet concept is designed to reduce fuel burn and hence CO2 emissions. And furthermore, we additionally expect significant potential to reduce NOx emissions and contrail formation at the same time. The latter two are the two major non-CO2 emissions driving climate impact of aviation. Wet uses residual heat from the engine's exhaust gas to evaporate a second working fluid, being water, and re-injected the water vapor, into the combustion chamber, increasing fuel efficiency and reducing NOx emissions by about 80%. A subsequent condenser is used then to condensate the water in the exhaust stream, forming water droplets, which are then being separated from the flow by what we call a water recovery unit. During the condensation and water separation process, we expect soot particles being washed out and filtered out, which leads to a significant reduction of contrail formation. In our consortium, Collins will develop the condenser, whereas MTU is responsible for the water recovery unit and the steam turbine. GKN will develop the vaporizer to evaporate the water, and Pratt & Whitney will be responsible for the development of steam injection into the combustion chamber. The water-enhanced turbofan will be able to burn jet fuel, sustainable aviation fuels, as well as hydrogen. And as a gas turbine-based concept, possible application ranges are short, medium, and long-range flights. Therefore, it covers ranges where almost all the aviation sector's climate impact is generated. Now back to you, Graham, for some words on hybrid electrics.
Thank you, Klaus. Over the past decade, hybrid electric has been one of the key technologies that Pratt & Whitney has been maturing for our next generation propulsion systems, and we are just really excited to have the ability to demonstrate this capability on a GTF engine as part of Switch. We'll be leveraging the versatility of electric powertrain technologies, and Switch provides us an opportunity to build on our already game-changing GTF architecture in that regard. In the projects, we're going to expand upon the learnings from several other hybrid electric demonstrator programs, and we'll continue to leverage our close collaboration with Collins Aerospace. For Switch, our hybrid electric GTF will introduce high-power electrical motors in a parallel hybrid configuration on both the high and the low spools of the engine. These two electric machines will enable the engine to operate more efficiently across the full flight envelope, using electrical augmentation to eliminate traditional gas turbine design constraints, providing additional power as well as optimizing engine performance throughout the flight envelope. The hybrid electric GTF powertrain will enable even greater efficiency across all phases of operation, including, for the sake of example, electric taxi, takeoff boost, our step climb as well as during descent. This capability will enable a wide range of advantages, including reduced emission fuel burn, reduced emissions, as well as improvements to local air quality and noise, while also improving the reliability of the engine. As part of the combined concepts, we intend to optimize the hybrid electric propulsion system with the wet engine throughout all of the flight envelope to ensure that we have an optimum combination. The electrical powertrain system team, comprised of Pratt & Whitney, Airbus, and Collins, will leverage industry-leading electrical machines, power electronics, high voltage distribution, as well as batteries to optimize performance of the fuel burning gas turbine. Pratt will be responsible for the engine integration design, electrical machine thermal management, and the hybrid propulsion control system. While this phase culminates in an engine ground demonstration in late 2025, we also look forward to performing a flight demonstration of the system as early as 2026, subject to the demonstration of technologies as well as future phases of funding. So now, Mary, over to you.
Thanks, Graham. First of all, let me say Collins Aerospace is proud to be a governing board and founding member of Clean Aviation, and also a key contributor to several areas within the Switch project. As Graham mentioned, Pratt & Whitney Hybrid Electric Gear Turbofan will introduce high-powered electric motor generators in a parallel hybrid configuration. For this, Collins will provide a 500-kilowatt motor generator in power electronics for the high spool and a 1-megawatt motor generator in power electronics on the low spool. This technology will be informed by the development of our 1-megawatt motor and motor controller for the Pratt & Whitney Canada Regional Hybrid Electric Demonstrator. We will deliver industry-leading power density and efficiency. Collins will perform demonstration of the Switch integrated electric train at The Grid, our state-of-the-art 25,000 square foot electric power system lab in Rockford, Illinois, slated to open in next year, 2023. Our next generation of electric power systems builds upon Collins' long history of aircraft power generation, with decades of experience supporting key electric aircraft programs like the 787 and the A350. Now looking over at the aircraft energy management and integration, what I want to talk about here is in order to support the hybrid electric power systems, new high voltage distribution technologies will be required as electric power levels increase from hundreds of kilowatts in today's aircraft to megawatt levels in the aircraft of the future. Safely handling and managing the distribution of high voltage, high power electricity at altitude is critical to prevent issues such as arcing or partial discharge. It's not just about generating more power, it's about being able to control, protect, and manage the power and thermal management within this environment. High efficient power distribution and conversion is required to maximize the use of available power and minimize the thermal losses within the system. Collins power distribution content for Switch includes much of these safety elements: relays, contractors, circuit breakers, and switch protection. Another area of Collins' contribution to the Switch project includes the nacelle architect. In this area, we'll be studying nacelle concepts that will optimize integration of the condenser for the wet engine and maximize thrust reverser functionality. I will now turn it over to my colleague, Henrik from GKN.
Thanks, Mary. GKN Aerospace is a world leader in engine system and a founding member of Clean Aviation, committed and excited to invest in the Switch project. From our GKN Aerospace engines team in Sweden, our involvement in this project includes development of engine structures with all new functionalities such as integrated electric machines and heat exchangers. We will also be contributing with thermal modules testing at one of our unique hot test rigs in Trollhättan, Sweden, validating thermal functionality to technology readiness levels 4. In the project, GKN Aerospace is also teaming up with Chalmers University of Technology in Sweden for aerothermodynamic validation at another unique turbine exhaust test facility hosted by the university. GKN Aerospace Fokker business in the Netherlands is also involved in this project, the team is developing the high voltage electrical wiring interconnection system called EVIS for the electrical motors developed by the Collins team in this project. So, Karim, would you like to take us through the Airbus work in the scope of this project?
Yes, of course. Thank you, Henrik, for the transition. And again, what you mentioned on the high voltage electrical wiring and network is very good transition towards the challenges that we have, not only in terms of new technologies assessments, but also the integration at the aircraft level. So I think what has been previously mentioned is that weight and hybridization can, on one side, of course, improve the turbofan efficiency with all the important impacts on the pollutant formation and also the contrails, but it can also reduce the CO2 emissions, thanks to more electrification of some key functions. I think Graham already mentioned that we can rely on this more electrification on some dedicated functions like e-taxi, step climb, takeoff boost, and even relieve the thermal engine in some function operation. This is very important. This is what we need to leverage. And in addition to that, this approach can also allow us to recharge the battery during the aircraft cruise. Our role within Airbus, with all the partners that are around the project, is to assess that this approach is beneficial at the aircraft level with simulation tools, with data from ground tests to define the best functional and control strategy that will allow us our common ambition of 25% of fuel reduction. This is very important for us. The whole optimization, the system optimization, which is key, is around managing the energy at the aircraft level in such a way that the benefits are not killed by the added weight that we are providing with the new technologies. This is the challenge that we have in front of us. One of the key elements in this challenge is linked to the energy storage and the battery topic, as already mentioned. And we are all together, not only Airbus, but we are all together monitoring this technology and how this technology is evolving in terms of higher energy densities. We know already that we will have to rely on our next generation of aircraft on batteries that will have to double their energy density, the energy density that we have today. And this is a key element. On that topic, within Airbus, we will rely on our experience on batteries for satellite application with our Airbus Group Chamber of Reference that will define the battery requirements and also define or at least scout the best cell technologies. This group is also capable of prototyping modules and battery packs that we could use for ground tests and finally for demonstrations. Again, this ambition is not done for nothing. New propulsion technology will play a key role to achieve our carbon neutral ambition. It's not a nice to have, it's a must. We know it already, and it's important that we start all together as a team, as partner, to explore those technologies, make them not only flyable, but also certifiable with the right level of benefits that we could get at the aircraft level. It's a teamwork, and we know already that by 2050, we will have all to cross the final line. Now, back to Klaus.
Well, thank you very much, Karim, for your contribution, and same to Mary and Henrik. So I think everything is said, and I would like to summarize our big ambition here. Switch is designed to work as an integrated system with hybrid electric and wet technologies, targeting up to 25% improvement in fuel efficiency and reduced CO2 emissions compared to today's state-of-the-art propulsion systems for short and medium-range aircraft. Switch will also enable an 80% reduction in NOx emissions and significantly reduce contrail generation. Switch supports Clean Aviation's goal of achieving a 30% improvement on the aircraft level in fuel efficiency and emissions for future short and medium-range aircraft. Switch is fully compatible with kerosene or SAF, so the potential reduction on climate impact of future aircraft could be even greater using SAFs. We will also evaluate Switch technologies for use with hydrogen fuel. We should underline here that current funding announced today supports phase 1 of Switch, extending to 2025, and will include a hybrid electric ground test on a GTF engine, wet technology rigs and preparation for cold section and hot section subsystem rigs, as well as design activities around hybrid electric and wet cycle integration. Successful lab, rig, and engine ground testing of key technologies is expected to lead to further high-fidelity analysis, ground, and subsequent flight testing in future phases. As has hopefully become clear, Switch is bringing together a group of world-class industrial and research parties into one highly accomplished team capable of developing these technologies into an aircraft-level system in a holistic way. We are all highly excited to be part of this clean aviation supported project to help enable the greener future for aviation, which is our whole industry is striving for. And with that, having said, I'd like to hand back to Marcus to moderate the Q&A session. Thank you.
Thank you, Klaus. Thank you very much for all your contributions. The speakers are now through with their presentation. They are ready to take your question. Just as a reminder, I already see the hand raised by Dominic. Just as a reminder, raise your hand in the Teams, and then we see the order of the questions, how they come in, or the people want to ask them, and then I will name you, and you can ask your question. If you want to indicate a specific speaker, please feel free. So the first one is Dominic Perry. You have to unmute your microphone, Dominic.
Sorry, and I expected everything to be done for me. Apologies.
No, we can just activate or deactivate it, but if we activate it, you have to mute or unmute.
Okay, so a question for Klaus to start with. What's the total funding for the project, and what's the split between public and private, and between Clean Aviation and UK research and innovation? And a question for Graham. This is quite similar technology to the systems you're researching on HiSight, which is a Pratt & Whitney program. How much overlap is there between the two?
Hey, if you guys want me to get started, Dominic, I don't want to comment on the total funding question. In terms of numbers, you can expect a number of several 10 million euros, which is contributed to that project in phase 1. And I also don't want to comment on the split between Clean Aviation or Europe and the UK on the other side. It's a significant support for the industry. In terms of the split between industry and funding contribution from official sides, you can assume roughly a 50-50 share.
Okay, thank you.
Yeah, and relative to the question on the difference between the Pratt & Whitney and Department of Energy sponsored HiSight project and Switch, what we'll note is that the Switch concept is really focused in terms of its primary fuel being sustainable aviation fuel and kerosene. It will be evaluated for hydrogen, and the HiSight technologies are specifically focused on the utilization of cryogenic hydrogen in terms of its primary design fuel. So, I'll state that they're related, but there are some significant differences in terms of the heat exchanger media when we're talking about air versus cryogenic hydrogen from the condenser perspective, as well as the other heat exchangers. But similar in terms of overall concept and sharing several, I'll call it, component of technologies that will be evaluated for both of these concepts.
Thanks.
Thanks, Graham. So then Richard Schuurman is the next one.
Hello, can you hear me and see me? Yeah, hello. A question to Klaus and to Graham. This is a combination of hybrid electric on the GTF side and the wet concept from the MTU. A question to Graham, how much is hybrid electric part of your development plan for the GTF? And is that a trajectory you are going along even without the Switch project? And a question to MTU, how is this hybrid electric now becoming a part and essential ingredient of the wet concept? Do you need them, both technologies, or can you develop them separately? Thank you.
Yeah, okay, so there are the capability of splitting them apart, but there is more benefit. And if we look at the, so we're going to have electrical motors on both the high and low spool, and that's going to enable us to do some unique operability with those engines than we would have done with the primary thermal engine. And we will also be looking at the requirements of the wet cycle as part of that overall optimization equation, and the portion of the project is to work that optimization from the perspective of predominantly efficiency, but we'll also look at certain elements such as contra generation as part of that.
Maybe, Graham, I can add something into that. I think it's important to capture that obviously the technology can work separately, but the idea of this project and the teaming we are having here is to explore how opportunistically we can combine both of them to increase the size of the benefits. And this is very important because this is at the end what we will need for 2050.
Absolutely.
Richard, I'd like to answer your question as well relative to the wet concept and opportunities to do that as a standalone versus synergistically with the hybrid electric. I'd like to state that we see a lot of benefit in doing that synergistically with the hybrid electric concept. And I would like to quote two examples. One is the wet concept obviously has very large heat exchangers, as you could have seen on the picture before, which will drive some impact on the transient operation of such an engine. And we think that with the combination with hybrid electric, there is a significant opportunity to counteract that drawback. And my second example would be relative to emissions. While the wet engine is very favorable in addressing all relevant climate impacting emissions in the cruise phase foremost, the hybrid electric concept offers a very nice potential in terms of local air quality around the airport, which we feel is also a very nice synergistic contribution.
Yeah, and if I may add one more question to Graham, is the hybrid electric something you are exploring and researching for the second generation of GTF as well?
Yeah, this would be complementary to our efforts for that second generation hybrid electric. We'll be utilizing the similar systems to components. The electrical powertrain elements will be, similar, same demonstrator activities. Obviously, we'll be looking to optimize through the course of the execution of the project. And as we've already discussed, the overall integrated system will be optimized for operation as a hybrid electric wet GTF engine, which will enable us to have, say, significant integration within the engine powertrain components, the electrification as well as the wet, but it's also going to enable greater integration into the aircraft electrical systems as well. So that combination is what we're going to be working to optimize to the aircraft level.
Thank you.
Thank you. So the principle of raising hands seems to work quite well. You see two more hands raised there. Next one is Thierry Dubois.
Hello. Bonjour, thank you very much for the opportunity. Question on technology readiness levels. Could you please let us know where you are starting in terms of TRL? What is your goal for the end of phase 1? And what would be the goal for potential phase 2? So could you please clarify, by the way, what phase 2 would be about? It's about flight testing, but please clarify. Thanks.
Who can answer this question?
I can start with wet.
I can.
Go ahead. I will go after. No, go ahead, Klaus. Sorry.
Thank you, Karim. Sorry. I can start with wet. Thierry, we are on our path to think about the wet concept and mature the technology with German national funding for quite a while now. So we will be at a technology readiness level around 2.5, 3 for some components, and for the system maybe 2.5 towards the end of this year. and we are striving for a TRL4 level by the end of phase 1 of Clean Aviation for the wet-specific technology content. And looking into phase 2, which spans from 2026 to 2030, as you probably know, we are looking into an integrated ground and hopefully flight test for the overall switch concept. So that would put us into a TRL6 area by 2029, 2030 timeframe. And maybe somebody else would like to comment on the hybrid electric.
I can do it.
Yeah, hybrid electric technologies, we're coming again at the base of technology at this point. I'll say TRL2 in that perspective, and then we're planning to accelerate TRL5 with ground tests in 2025.
Sorry, I can't hear you. The line is very broken.
Oh, I have my microphone off, sorry. Yeah, okay, leave my microphone off. Can you guys hear me? I don't see my microphone on.
Sounds better. Sounds good.
Okay, you guys can hear me?
Repeat the TLR you mentioned.
Yeah, TRL3 at this point, and then we'll be progressing it to TRL5 with the ground test.
Okay, so I can, last one I guess will be on my side. In terms of functional architecture and integration, we won't go into the demonstration before reaching TRL4 to 5 at the end of phase 1. And this is our mission, and this is what we want to reach.
Okay, so Thierry, your questions are answered. Then I would
Yes, thank you very much.
Thank you very much. I'm not sure who can answer this question, but is the primary objective of all of this work to convert existing airliners to hybrid electric propulsion, or is it mainly intended for clean sheet designs, or perhaps both? And in either case, what's your best estimate of when the first hybrid electric airliners will enter commercial service, and what sort of size will they be, and what's the timeline for scaling them up?
I can start, because this is a very good question from Charles. Let's be very straightforward. The objective of the project, Charles, is to explore this hybrid approach along with weight technologies, and to ensure at the end that the size of the benefits that we are expecting are there. Okay? Because at the starting point of this project, we have a direction, but we have not yet assessed all those topics. So this is the very first step. When we will assess that, there will be a key milestone to assess what will be the platform for demonstration. And afterwards, we will try to see what is the value and what would be the benefits for the customer and the airliner. So far, this is how we see that. The objective being to have a sort of entry into service not before 2030 or 2035, which means that we have time. And importantly, what we need to do now is this assessment. And why is it so important to do it now? Because as I mentioned previously, it's a teamwork. We cannot only rely on the technology assessments by itself. We need to put those technologies into a system architecture and do the assessment at the aircraft level, because all the aircraft functions are impacted. So we are not talking of more of electrification. We are talking of a new aircraft that will be fully hybridized. So it's not the same question, and this is why we need to know to do it in a very staged way.
Thank you. That's very clear. Thank you.
Any additional comments from one of the others? No. Then we'll take this as the answer, and I would like to hand over to the second, to Björn Firm. You're the next one.
Okay, hello everyone. I would like to ask whether there is a copy of the presentation, because funnily enough, the warning that the meeting should start didn't work on my computer, so I joined late. So is there a way to get the presentation?
I will check with my colleagues, but I think we can send it over to you after.
Yeah, please do. Because the Teams, I checked, Teams didn't trigger my, it should trigger half an hour before and then 10 minutes before.
didn't really trigger anything. So anyway, thanks.
Okay. Any further questions from the media representative? Dominic again, and then
So I was just wondering what sort of weight penalty you'd be expecting from the additional equipment, the condensers and evaporators and whatever else is going into the wet system.
Hey, if you guys allow, I'll take that. So we did a very initial estimate based on our cycle analysis theory, and we looked into what we think we can achieve in terms of technology parameters for pressure losses, as well as heat exchange rates for the condenser and the evaporator. And you could roughly expect that the engine, or I have to say the propulsion system, will grow in weight by about 50%. So we go from 100 to 150, roughly. And now we have to obviously integrate that with the aircraft itself, with the wing, and that's work Airbus is currently doing, and we are jointly doing, obviously, in that switch program. And then we will have to figure out what the best way would be for integration. That's, by the way, one of the biggest challenges, obviously, of such a propulsion system. And then we will see where we end up on a system level. I'd like to point out, though, that weight increase is by far significantly overcompensated by the SFC benefit we will get. So in the end, on a fuel burn level, on a system level, that engine obviously provides, or that concept obviously provides significantly to the overall 25% fuel efficiency benefit.
Okay. So the engine is how much more efficient on its own, and then factor in the weight penalty?
Yeah, I don't split those numbers for you. I apologize.
Okay, that's fine. Another question, if I may. There's been quite a lot of talk about the second generation GTF, and MTU has been quite open in participating on that. Should we think of the technologies being developed here as GTF version 3, or does some of these supplant GTF version 2?
Graham, you want to take that?
Yeah, I think, here's what I have to say is that whether it's 2 or 3 is dependent on, how this technology collectively matures. At the point in time that there is an opportunity for, a new application and a new GTF engine, we're going to take everything we can get and leverage that, for maximizing the benefit to our customers. And so right now it's not feasible, or it's not possible for us to say whether it's 2 or 3. It's really dependent on how well all these technologies mature and develop over the course of this project, as well as the others that we're actually shooting in parallel.
Okay. So these could feed into generation 2 if the airframer requirement isn't there in a shorter period of time, I suppose.
Yeah, I mean, here's how it'll work is, we're going to bring our technologies to the table. We'll work with the airframers. As we've already kind of communicated, this is a highly integrated propulsion system with the airframe. So obviously, you need a lot of interaction and a lot of involvement with the airframers so that they can actually understand how to integrate the propulsion system and obtain the maximum benefit from it. And so that's why we're doing these types of activities.
Good. Then Richard Schumann again.
Yeah, thinking about what Karim said about the time schedule, what Graham is saying, is this your response to the CFM RISE project, the open rotor? They're going that way, and you are going for a wet concept with a hybrid electric ducted fan or ducted engine concept. Because in some way your time schedules are coming together in the 2030, 2035, when General Electric and CFM have said they want to have something available from the RISE project.
I think from a family perspective, that we are working this as we're rolling out any potential application our customer may want in terms of its overall configuration. Certainly, from what we're doing here and what we communicated in the past, we do tend to be more bullish on a ducted turbofan and using the benefits of electrification combined with a tank cycle, wet cycle, such as what we're discussing today, to extract energy out of the fan. It's thermodynamically, it's a very, shall we say, feasible cycle. It's down to design execution, and that's something that we have historically done well on in the past. We don't see, a number of the challenges that have been identified with the open road concept that we're well aware of. But nonetheless, if that's where our customers want to go, we will certainly adapt and develop a cycle or a propulsion system that will support their requirements and their needs.
And if I may, Graham, I would just add to Richard's questions, just a comment, just saying that there's nothing around competition on that topic. It's much more around exploring the benefits of electrification on different options of turbofan. And again, there's no mystery around this. At the end, we need all those technologies. So this is why this, what I call this wide exploration that we are doing today together is key. We need to open all the options before going into a sort of competition. It's not yet the time of competition, it's the time of assessment.
Okay, so then once again, Thierry Dubois.
Thank you. I would like first to ensure I have properly understood Klaus when he commented on the weight penalty. I noted that I'm not sure I understood properly that the weight penalty from the wet system would be in the order of 50% on the engine. Is that correct?
Yes.
50. Okay, thank you. And then a question maybe for Karim or anyone who wants to take it. Could you explain why this propulsion system will be much more integrated with the aircraft than today's propulsion systems?
Très bonne question, which is basically in English, very good question. It will have to be much more integrated because I think Graham mentioned that everything is around the energy management and everything is on the way we will manage power and energy during the profile mission to ensure that the electrification approach along with the weight will be beneficial and as much beneficial as we need. And in order to do that, you will have to rely on a different voltage network than the one that is existing today. You will have to integrate electrical motors, you will have to integrate a battery for the key components, and therefore the way the integration will be done along with what we call the figures of merit, which is basically the performance of the brick, the way we will manage the energy and the power are the key issues you need to explore and master to make the whole thing beneficial. And therefore, it's no more a question of more electrification. As I mentioned it's not a question of more sauce in the salad. It's much more a question of how I build the salad around the sauce. And this is relying on integration.
Thanks.
Very nice picture of the salad. Thank you for that, Karim. So Joanna Bailey is next.
Thank you, and thank you for the presentation, guys. Very interesting stuff. I just wanted to ask about the airplane technology that these solutions are being designed for. Are you looking at this as something that could be fitted to existing aircraft technology, like an Airbus A320 or a 220, or is this something that would require an entirely clean sheet aircraft design in order to work with it? Thank you.
Bon. I think the easy answer would be we are exploring and therefore we do not know yet, but I'm not sure you will be satisfied with this answer. So the objective really, and again, very transparently, is to explore the benefits of the approach. The idea is to create value for our end customers. And when you mix those two items, if there are some opportunities on which we could rely on the existing products to integrate the technology and make it viable, that will be Okay, fine. But we see from the discussion and the presentation that there will be an impact in terms of architecture. So therefore, there will be a trade between the investment that we will need to do in front of the benefits. And this is why the key topic is around this exploration to increase the size of benefits. If we are not achieving the benefits, the investment towards the value creation won't work.
Okay, so I see Björn, you raised your hand, but you put it down again. So there's no question, obviously.
No, I made a mistake. I do have a question. Okay. Given that I haven't seen the whole presentation, I have to understand, I know the WECT concept as described both by MTU in detail in reports, and I also know what Pratt is working on in terms of working with the water in the exhaust of engines. What I don't quite understand is the hybrid part, because I haven't seen the whole presentation, but I do know that one of the real difficult parts of the hybrid is the batteries. So could you explain to me, first of all, I understand that 50% massive increase is because of the wet condenser, the wet parts of a turbofan or a gas turbine engine. So what are the weight or mass consequences, more correctly, of the generator, the motor, and the battery part of the hybrid?
Okay, I can start. Again, very good question. So the weight penalty is the key topic, okay? Because in comparison to other industries, we are not recovering energy during braking, and therefore we are making traveling or cruise the weight of the battery and the electrical motor. And what is important again is to ensure that there are benefits, so that the benefits are not killed by the overweight. This is what I mentioned during the presentation. And this is why the system approach, the functional approach, and the energy management are key, because we need to size the electrical systems in such a way that we are making those benefits, and it is feasible, okay, at the aircraft level, and this is so far our first assumption. If you want some figures in terms, I think it's too early today to claim some figures in terms of overweight, but there will be something that will be probably around 1 ton of overweight, but this is how we need to make it beneficial with this drawback. And again, into that, the key technology that will pave the way towards more benefits is the battery. And we know today that those technologies are step by step evolving, and this evolution is much more triggered by what the automotive industry is doing today. And we will have step by step to go into more energy densities than what we have today. And the good news is that those high energy levels that we need for our next generation of aircraft are the ones that will fulfill the needs of the automotive industry when it comes to fast charging and long ranges. So the electrification trends today are going towards much more benefits in terms of energy storage, and this will allow us more and more to make the hybridization approach beneficial at the aircraft level.
Okay, I have to disappoint you that I probably passed and calculated this on a rather high professional level about 100 times, and I have never seen it work. Okay, so the hybrid part is really the one I would like to get the slides, because the hybrid part is the one that I'm not convinced of. I'm totally convinced about the wet concept and the work by Pratt & Whitney, with the whole water management and so forth. That's really stuff that can work, but the hybrid part is, I never made it work, and I work on a high level as a performance engineer.
Yes.
So I would like to have some more facts there. So first of all, the presentation, and then I would like perhaps to book a call that we can have a deeper discussion and compare my figures with your figures.
You are welcome. But as a hint, what I can tell you is that, of course, I fully understand your point of view, and this is linked to the way you have designed your propulsion system and the benefits of electrification. But happy to discuss with you.
Yeah, okay, good. So then we can agree that.
But I know exactly what you mean, because we made those calculations, and it took us a little bit of time to, let's say, reframe the electrification approach in a different way than just getting the benefits from the propulsion system.
Okay. that's fine. So I have seen one hybrid system that has the potential to bring some benefits, and the key thing about this hybrid system was the smart way they actually almost got rid of the battery. So the smallest possible battery, that's how you could break it to actually have some benefit. If you have a large battery in the system, they basically virtually sinks the system.
I agree on that point.
Okay, so we'll make a separate call on that.
So beyond this big question Björn was now posing into the audience, I don't see any further raised hands in the pipeline or questions in the pipeline. So in a certain way, this could be a kind of last call if you have something. Otherwise, I would move in the direction of closing this meeting. Dominic?
Yeah, one more from me, and this might be a little bit speculative. If you bring this to market, do we see this as a Pratt & Whitney engine, or do we see this as something like the International Aero Engines, that type of consortium?
I think we're not that far along yet. I think we'll just stick with this as a consortium of a fantastic partnership with people that are all looking to explore and develop technologies. And should this end up in a product, we'll kind of determine how that works in a mutually collaborative and beneficial fashion.
Okay, so then we have the last question for this call from Thierry.
Yes, please. I'd like to hear again a summary of how water injection enhances the way the engine works. It's not quite intuitive, I have to say.
Okay, so maybe I take that, Klaus. The water is the second working fluid, which is going to be evaporized by heat from the exhaust stream downstream of the LPT tech of a normal engine, and that heat will be recovered by transferring it via the water back into the combustion chamber. So that's a huge specific fuel consumption benefit, because you save waste energy and reuse it in the combustion chamber. That's one. The other one is dumping the water vapor into the combustion chamber, very similar to what we do on industrial gas turbines, significantly equalizes or evenly distributes the temperature profile downstream of the combustion chamber, and therefore reduces building of thermal NOx. And that's a significant contribution relative to emissions.
Thanks.
Yep.
So we have one final question from Ulrike Ebner. This will then be the last one for today.
Okay, thank you very much. We heard about weight penalties, but what about the length and the diameter? How would it be affected by the wet and the hybrid electric concept? Thank you.
Maybe I start with the wet side, Ulrike. The diameter is not affected at all. It's the same propulsor, more or less, on the wet engine. The length of the engine is significantly increased because you have to make room for the heat exchangers, as you probably suggested already, which will contribute to the drag of the propulsion system, which is in the overall bookkeeping. That will be a negative, as the weight is a negative, as opposed to the SFC improvement, which is a positive. And we quote an overall fuel burn improvement. That's how we keep that stuff. So drag will be increased because of the length of the engine. That's absolutely correct.
Any additional comments from any of the other speakers?
Graham, could you repeat, please?
The sound is not working well, probably talking a bit slower because of the transmission rate.
Yeah, maybe. I was just saying.
Not really better now.
Okay, well, why don't we just, I'll pass.
Sorry. Okay, so then, thank you very much for all your questions, and of course, thank you very much to the speakers for all the answers. For sure, over the course of the project, we will have further occasions to talk about Switch. For today, when I look at the timing, it's right in time. I would like to close this first media session right now. Thank you very much to all of you. Thanks to the speakers. Thanks to my colleagues in preparing this media briefing over the past weeks. And of course, a very big thank you to you, the journalists, for participating and taking the information, sharing the information then after the embargo. I just wrote it into the chat as well. Embargo will be lifted tomorrow, November 29th at 6 a.m. Eastern Standard Time, which is noon in Central European Time. We will at this point send out the press release. Anyway, you get the press release right after this meeting now under the same embargo conditions to have something to get the information from, and together with the information from the media briefing, you can prepare your reports even in advance. Okay, thank you very much, and see you soon.
Thank you, bye-bye.
Bye.
Have a great day. Bye-bye.
Thank you.